Voyager 1, the cosmic messenger, unveiling the unknown. In the vast emptiness of interstellar space, where silence reigns and the laws of physics stretch to their limits, a relic of human ingenuity has defied all expectations. Voyager 1, the most distant human-made object in history, has been drifting through the cosmic abyss for nearly half a century. Launched in 1977, this spacecraft was designed for a modest mission to explore the outer planets and fade into obscurity. Yet, after 48 years and over 15 billion miles traveled, Voyager 1 has not only endured, but has sent back a signal that has left scientists reeling. For months, it transmitted nothing but garbled noise, leading many to believe its journey had ended. Then, in a moment that defies explanation, the signal returned, coherent, clear, and carrying data that challenges the very foundations of our understanding of the universe. A Nobel Prize-winning physicist has issued a stark warning. This changes everything. What has Voyager 1 discovered at the edge of interstellar space? And why are experts whispering that this could be the key to unraveling the greatest cosmic mystery of all? This is not just a space mission. It may be humanity's first encounter with the unknown. A historic journey born of cosmic serendipity. Voyager. One story begins with a rare celestial alignment that occurs once every 176 years. In the 1970s, the outer planets, Jupiter, Saturn, Uranus, and Neptune, aligned in a way that allowed NASA engineers to craft an ambitious mission known as the Grand Tour. By using the gravitational pull of each planet to slingshot Voyager 1 to the next, the spacecraft conserved energy and achieved velocities far beyond what its modest thrusters could manage. Equipped with 1970s technology, less computing power than a modern smartphone, Voyager 1 was built to last a decade at most. Yet, it has endured the harshest environment imaginable: the radiation belts of Jupiter, the icy voids beyond Saturn, and the unrelenting cosmic rays of interstellar space. After its flybys of Jupiter in 1979 and Saturn in 1980, Voyager 1 was flung outward, leaving the planetary realm behind. It crossed the Heliopause, the boundary where the sun's influence wanes, in 2012, becoming the first human-made object to enter interstellar space. Now, at over 15 billion miles from Earth, it travels through a realm where no signal had ever been sent or received until Voyager 1 broke the silence. Its longevity is a testament to human ingenuity, but its latest transmissions suggest it has stumbled upon something far greater than its creators could have imagined: the silence and the signal. In late 2024, Voyager 1 fell silent. For months, the spacecraft sent back nothing but corrupted data, a jumble of ones and zeros that suggested its systems were failing. Scientists at NASA's Jet Propulsion Laboratory, JPL, feared the worst. After 48 years, the spacecraft's nuclear power source, a radioisotope thermoelectric generator, was finally depleting. The mission, it seemed, had reached its end. Then, in April 2025, something extraordinary happened. Voyager 1 began transmitting coherent data again, as if it had been rebooted by an unseen hand. The signal was not only clear, but carried information that defied all expectations. The data revealed unusual plasma fluctuations, erratic shifts in magnetic fields, and a surge in particle density unlike anything observed in interstellar space. These readings were not merely anomalous. They were impossible by current scientific standards. One astrophysicist at JPL remarked, "It's as if Voyager 1 is no longer just outside the solar system. It's outside something else entirely." The orientation of cosmic rays and magnetic field lines was misaligned. suggesting the spacecraft had crossed into a region where the rules of physics behave differently. No model of interstellar physics can yet explain these phenomena, raising a chilling possibility. Voyager 1 may have entered a new kind of space, a transitional zone where our understanding of reality begins to unravel. Beyond the Heliopause, a turbulent frontier. When Voyager 1 crossed the Heliopause in 2012, scientists expected it to enter a relatively calm region of interstellar space, a vast emptiness dominated by the galactic magnetic field and sparse cosmic particles. Instead, the latest data paints a picture of a dynamic, turbulent frontier. Voyager 1 is detecting plasma waves, charged particle storms, and gravitational anomalies that lack a consistent source. The spacecraft's trajectory has shown subtle, unexplainable drifts, as if influenced by forces beyond the pull of stars or the collisions of asteroids. These anomalies suggest that interstellar space is not the empty void scientists once imagined, but a complex, structured region that challenges our assumptions. Among the most intriguing findings is a rhythmic fluctuation in the data, a pulse emanating from a region Voyager 1 recently traversed. This signal is not random background noise. It is structured, timed, and repeating with eerie precision. Initially dismissed as instrument error or interference, the pulse persisted, matching no known stellar phenomenon. It is not the signature of a pulsar, a quasar, or any recognized source of radiation. More unsettling, the pulse appears to react to Voyager's transmissions, increasing slightly after each data burst, as if something is listening and responding. This discovery has sparked intense debate, with some scientists cautiously suggesting that the signal could be artificial in origin, a possibility that, while speculative, cannot yet be ruled out. A cosmic grid and the shape of reality. As scientists analyzed Voyager's magnetic field data, a startling pattern emerged. When visualized in 3 dimensions over time, the variations formed a spiral framework with near-perfect symmetry. This structure, dubbed a cosmic grid by researchers, is unlike anything observed in astrophysics. It is not random noise or the product of stellar winds. It resembles a gravitational lattice, a scaffold that seems to underpin the fabric of space itself. Some propose it could be a natural phenomenon, perhaps the result of unseen dark matter or exotic particles. Others venture further, suggesting it might be the signature of an artificial construct, a relic of a civilization or intelligence far beyond our own. The implications of this discovery are profound. If the cosmic grid is real, it could indicate that interstellar space is organized in ways we cannot yet comprehend. It might point to the existence of a larger cosmic architecture, a framework that governs the behavior of galaxies, stars, and perhaps even the universe itself. For decades, theoretical physicists have speculated about the possibility of a multiverse or simulated reality. Voyager 1's data, while not conclusive, provides the first empirical hints that such concepts may be more than theoretical. The spacecraft, carrying humanity's golden record, a message to the cosmos, may have stumbled upon the first evidence of a reply. Variable dimensional space, a new frontier Voyager. One's onboard systems, though aging, have begun behaving in ways that defy explanation. Its orientation sensors report conflicting positions, as if the spacecraft exists in multiple coordinate spaces simultaneously. Its signal shows tiny variations in transmission speed, suggesting it is passing through regions where space-time itself is distorted. These anomalies are not consistent with instrument decay or cosmic radiation damage. Instead, they align with theoretical models of variable dimensional space, a concept once confined to the realm of science fiction. Variable dimensional space posits that certain regions of the universe may possess additional spatial dimensions or altered physical constants. Such a region could explain Voyager's erratic behavior, as well as the gravitational and magnetic anomalies it is detecting. If confirmed, this discovery would rewrite our understanding of physics, suggesting that the universe is not a uniform continuum, but a patchwork of domains with distinct properties. Voyager 1, a 48-year-old probe with rudimentary technology, may be the first to encounter this frontier, revealing the true complexity of the cosmos. The Nobel Prize warning: a paradigm shift. The scientific community has long been cautious about Voyager's findings, preferring to attribute anomalies to instrument errors or incomplete models. However, in May 2025, a Nobel Prize-winning physicist broke the silence with a statement that sent shockwaves through the field. Voyager 1 is detecting patterns that cannot be reconciled with our current models of the universe, they declared. We may be seeing evidence of another domain, another structure of space itself. While stopping short of endorsing fringe theories like a multiverse or artificial constructs, the physicist's warning was clear. Voyager's data demands a re-evaluation of our assumptions about reality. This statement has galvanized researchers worldwide. Teams at NASA, the European Space Agency, and independent institutions are now racing to analyze Voyager's transmissions, using advanced machine learning and quantum computing to model the data. Early results suggest that the anomalies are not isolated, but part of a larger pattern, potentially linked to the cosmic grid and the mysterious pulse. The possibility that Voyager 1 has encountered a boundary, whether of another dimension, a simulated reality, or an unknown cosmic structure, has moved from speculation to serious consideration. The golden record and the irony of contact. When Voyager 1 was launched, it carried a golden record, a time capsule containing sounds, images, and messages from Earth. Intended as a greeting to any extraterrestrial intelligence that might find it, the record was a symbol of humanity's hope and curiosity. Now, nearly 5 decades later, the irony is profound. The spacecraft meant to deliver our message may have received one in return. The rhythmic pulse, the cosmic grid, and the gravitational anomalies all hint at a presence or phenomenon that defies natural explanation. While scientists remain cautious, the possibility of contact, whether with an intelligence, a cosmic construct, or an unknown force, cannot be ignored. The implications of such a discovery are staggering. If Voyager 1 has detected evidence of an artificial signal or structure, it would confirm that we are not alone in the universe. Even if the phenomena are natural, they suggest that the universe is far stranger and more complex than we ever imagined. Voyager 1, a product of 1970s engineering, has become an unlikely pioneer, revealing truths that challenge our place in the cosmos. The role of emerging technologies. The analysis of Voyager's data has been revolutionized by advancements in technology. In 2025, artificial intelligence and quantum computing have become indispensable tools for astrophysics. AI algorithms are sifting through terabytes of Voyager's transmissions, identifying patterns that human researchers might overlook. Quantum computers are simulating complex interstellar environments, testing hypotheses about the cosmic grid and variable dimensional space. These technologies have accelerated our ability to interpret Voyager's findings, but they have also raised new questions. For example, some AI models predict that the pulse could be a form of encoded information, though decoding it remains beyond our current capabilities. Citizen science has also played a role. Platforms like Zooniverse have engaged millions of volunteers in classifying Voyager's data, identifying anomalies that professional researchers can then investigate. This collaborative approach has democratized the mission, making it a global endeavor to understand the unknown. Social media platforms, particularly X, have amplified public interest, with posts speculating about everything from alien signals to multiversal boundaries. While some of these theories are far-fetched, they reflect humanity's deep fascination with Voyager's journey. The future of Voyager 1 and beyond. Voyager 1's power supply is expected to last until approximately 2030, when its instruments will likely shut down. Until then, every transmission is a precious opportunity to learn more about the interstellar frontier. NASA has prioritized maintaining contact with the spacecraft, reallocating resources to ensure its signals are captured and analyzed. Future missions, such as the proposed interstellar probe, aim to build on Voyager's legacy using advanced propulsion and instrumentation to explore the Heliopause and beyond. However, Voyager 1's discoveries have already set the stage for a new era of exploration. The anomalies it has detected suggest that interstellar space is a frontier ripe for investigation. Proposals for missions equipped with quantum sensors, plasma detectors, and AI-driven navigation are gaining traction, driven by the need to understand the cosmic grid, the pulse, and the potential for variable dimensional space. These missions could confirm whether Voyager 1 has indeed encountered a new domain, or whether its data reflects a misunderstanding of interstellar physics. A voyage into the unknown. Voyager 1 was never meant to go this far. It was designed to study gas giants, not to probe the edges of reality. Yet, 48 years after its launch, it is doing something far more profound, revealing the architecture of the universe itself. The spacecraft that carries humanity's golden record may have found the first hints of a cosmic reply, a pulse that behaves like a signal, a grid hidden in magnetic noise, and spatial glitches that suggest multiple realities. What began as a journey past the planets has become a voyage into the unknown, forcing Nobel Prize-winning scientists to rethink the nature of existence. Is Voyager 1 still exploring space, or has it crossed into a realm where space as we know it no longer applies? The answers may lie in its next transmission, which could be the message humanity has awaited since the dawn of time. As we stand on the brink of this cosmic revelation, one thing is certain. Voyager 1, our ambassador to the stars, has shown us that the universe is far stranger and far more wondrous than we ever dared to imagine.